Hello, welcome to the Flux V2, the GitOps Toolkit working group. Very nice to see you here. I'm going to give you a short overview of what happened in the last 2 weeks. So we have moved from Docker Hub to the GitHub container registry to host the toolkit controllers. And maybe you don't know the context. So starting in November, Docker Hub will apply a rate limit of 200 pulls per 6 hours for non-authenticated users, and a similar number for those that are authenticated but they don't have a paid Docker Hub account. While this was announced, also GitHub announced that they are launching their container registry service, which is compatible with the Docker registry API, and it has you can post their public images with no authentication required to download. So we instantly made the switch. And while we did that, we also published ARM64 images for those that are running on ARM Kubernetes nodes. We don't have images for ARM32, so for most Raspberry Pis right now, but as soon as GitHub will allow multi-arch layers to be pushed to the same container registry, will be publishing 32-bit images on top of the 64 one. So I know by next month you'll be able to run Flux V2 on no matter what architecture. Another thing that we've announced, we now have support for Git repositories in Helm controller. So you can reference a chart source as a Git repo. Source controller will clone that particular repository, will create a chart at that specific path, and Helm controller will install it the same way it does today with from a Helm repository. There are some differences in terms of implementation between Helm operator and the toolkit. In the current version, you have to push to Git the chart dependencies, so we don't do a dependency build like we used to do in Helm operator. Dependency build is a very expensive operation, and it also needs a lot of fiddling with authentication, because you can, even if you keep your chart in a Git repo, you can say in a dependency Helm depending on a Helm repository, and maybe that Helm repository has authentication and so on. So to avoid all of this, you right now you have to pull. You have to do a Helm dependency build before you commit the Helm chart to Git. The dependencies are there, so Helm controller will apply it. So that's on the Helm side, and this change comes with a breaking change to Helm controller. So if you have previously used Helm controller, you have to change some fields in the custom resource to make it work with the new version. Another thing we have released is Mozilla SOAPs support decryption for the toolkit in a similar way in how it works with Flux V1. It works in the same way with Flux V2. The major difference here is that you no longer can encrypt the metadata of Kubernetes object. So for example, in Flux V1, you could encrypt the name of the kind name. So if someone look at the YAML, you couldn't see if it's a secret or a config map. That's no longer supported, and the reason for this is that we use Customize as a library to build the manifests that are being applied on the cluster. And after we build the manifest, before applying them, then we run decryption. And Customize build will fail if you don't have the API version, the kind, and the object name in clear text. But I don't think that should be a security concern. You should be encrypting the Kubernetes secret data field, because that's where the actual secret is. So doing that will work fine. Other things that we'll be releasing this week or probably at the beginning of next week. There is we rewrote the garbage collector for customized controller. So what happened with Flux V1? Let's take Istio an example. If you deploy the Istio operator, then you create a custom resource. So the Istio operator will install the whole thing. Then you delete the Istio operator deployment and custom resource definition from your Git repo. What will happen with Flux V1? It deletes the deployment. All the custom resources have finalizers on them. Then it tries to delete the custom resources, the Istio custom resources. The finalizer will block the delete, and Flux will not be able to advance from that moment on. So no new commits will be applied and so on because the delete fails. The only way to fix this is to get in the cluster, edit all these custom resources, and remove the finalizers from them. And only afterwards, Flux will be able to delete them. And this can cause a cascading failure. For example, if a custom resource inside the namespace has a finalizer and is no controller running on the cluster to actually finalize that, also the namespace delete will be blocked and so on. So you can end up with a very bad state of the whole Git sync. In what we did in customized controller is we mark object for deletion. So we with the controller runtime, we send the delete command to the Kubernetes API. And from that moment on, we will not try to delete the object again. We send the command, we check that the finalizer has been set, and then it's up to the controller, that particular controller, to actually delete it. So it will not block the sync anymore. Let's say if you deleted a controller or you deleted a custom resource definition or whatever, the customized controller will mark all those objects for deletion, then it will continue with its sync. So it will not block forever and so on. Of course, if you want to get rid of those objects from etcd, you still have to manually edit them and remove the finalizers, but that's, in my mind, a good trade-off because you'll still be able to, keep synchronizing with Git and so on. That's it from me. Hide, you have something to announce?
Yeah, I've made big changes to the way the source controller, or I've optimized the way source controller does storage and reconciliation operations so that overall IOPS is way lower. For example, before the reconciliations were basically blind. So it didn't really check if the revision was a new one or not, and did a blind build of whatever artifact it was creating. This has been fixed. File writes are now atomic, so files won't suddenly disappear due to writes or whatever. Yeah, and other small technical optimizations like the checksums are now calculated during the write of the actual file instead of a two-stage kind of thing. That's about it, I think.
Yeah, so all this work is around making source controller use less resources and being better at writing atomic artifacts on this. The problem we had before was that consumers like customized controller, Helm controller could try to download an artifact that was being written on disk, and that will result in a untar error, and then we will retry the download and so on. And all of that is now sorted. Yeah, I want to invite Philip, if you want to talk about the case status pull request.
Let's see here. Yeah, can you guys hear me?
Hey, Philip.
Hey, hello. Yeah, so the work that I've done with the case status is basically fixing the health checks for the customization controller, so it works with other resources other than stateful sets, deployments, and I think daemon sets was the other one. So before, the health check is very dependent on the status that was specific to the resource to determine if it was healthy or not. So in the case of deployments, you know, if all pods are running and it's reached some sort of healthy state. So I think it was Sean or someone who posted something about case status, which is a part of this SIG CLI group, and to work with a separate tool to kind of unify how statuses are set for resources. So the work I've been doing is basically integrating case status into the health checks so that we could basically have any resource that follows the case status standards of how you're setting your status fields to do health checks. So the reason I needed this was explicitly to get Helm releases to work with the health check for the customization. So yeah, so it's mostly implemented. I think it's just some small tests that we need to do against the Helm controller right now.
Yeah, so case status, one of the things that it does, it looks up the status of resource of a Kubernetes object, and if it finds a ready condition, then it will pull that status until the ready condition it's true or false. While it's unknown, it will do a long polling. And what we allow you to set in the customization object is a timeout for the health check. So it will not pull forever and block everything. And because all the toolkit custom resources have a ready condition, then you can, let's say you have a customization that has a bunch of Helm releases, and you can say, I don't want to apply a new version on the cluster until all these Helm releases have reached the final state. They either failed or they are succeeded, and only then continue applying. And before, this was possible only by referencing the deployment inside the Helm release. And that can be quite tricky because then you have to know what deployments are in this Helm release, list them all, what namespaces, and so on. With this change, you can just say, for customization, you can give it a list of Helm releases, and then it's up to Helm controller to decide when all the deployments or daemon sets or whatever is in there reached a healthy state, then Helm controller updates the Helm release status and say, hey, everything is fine now. Then customized controller sees that change and resumes the operation. And also this works with notifications. For example, Philip implemented in notification controller a way to write back to the commit status on GitHub. So for example, now if you have a Helm release in a Git repository, you can define a way for the toolkit to write back to Git on that particular commit if a Helm release, if a bunch of Helm releases that are part of a customization have failed or not. So it's also an improvement to the overall observability of what's going on inside your cluster.
I think there's one behavior difference that I've implemented because of we're using case status, and I think it's before the timeout was per resource, if I'm not correct, or am I correct? So it would basically go through the list of references in the health check and timeout for each one, and that's different from how it works today or now after the PR gets merged, where the timeout is global for everything. So it will gather all the identifiers of all the resources it's going to health check, and then it waits for all of them to complete. So that's kind of maybe something if somebody is dependent on the fact that it works in the old way, to keep your heads up.
Yeah, the way I've implemented the first version was you set a timeout, then the customized controller will take each item in the health check list and take the first item, wait for it to resolve somehow for that timeout, then go to the next one and so on. And that could be, that's not ideal, right? Because if you have like 10 Helm releases or 10 deployments, you probably want for those to be monitored in parallel. And if the first one failed, bail out and raise an error. So yeah, the rewrite with case status is way better than what was before. Also in terms of parallelism, because it can watch all these things in parallel, and the timeout is for everything, right, Philip?
Yeah, exactly. What would be interesting is or what I'm planning in the future is looking at verifying that things work with Flagger and stuff like that. So I haven't actually looked at how Flagger sets some sort of condition on its resources. It might also be valuable to maybe keep a list somewhere of different types of CRDs that are compatible. We'd have to maybe add that or keep adding as time goes on. But I'm guessing a lot of people will come and ask, oh, health checks don't work for Tecton or for this random controller I'm using.
Yeah, what I think we should do, we should update the health assessment entry in our docs and document there what case status does.
Mm-hmm.
At least, we should list of okay, we have a ready condition, we have support for this one, and this one. So people will it's up to them to look up their own custom controller and see, does it have that kind of status object or not? So we should definitely document that. I think some of that information should be in the case status README, but if it's not, we should read the code and do the documentation on our own.
It's in the README, but it's not that. I'm not going to say not great, but it's a bit hard to understand for beginners. I'm guessing, so it might be good to just condense it a bit and then just say that if it reaches these types of requirements, then it's going to work.
Yeah. So I think that can come in another pull request. If you can test the Helm release pulling, and if that works, then I'm okay with merging the code changes, then do the documentation changes, and then do a release of customized control and the toolkit itself.
Yeah, it should be. I should be able to get it done by the end of the week. So I just have a lot of work to do during the weekdays.
Yeah, no worries. Thank you very much, Philip, for stepping in and helping us with that. We want to extend the commit status notifications to GitLab. So if someone has, I don't know, if you are using GitLab at work or something like that, that could be a good way to contribute. There is an example for GitHub right now, and knowing the API, it's very similar for GitLab. We just need to use the GitLab Go GitLab client to write to that to write the status API. It's quite similar.
If anyone does, if nobody wants to do that, I can probably do that already, because in the Flux status, I've integrated GitLab already, so I can just probably move the code.
Oh, nice, cool.
Yeah.
Okay.
So I'll create an issue or something.
Mm-hmm. Yeah.
And then maybe it's I'm just gonna sorry. I know that I'm going to need support for Azure DevOps. So is that something we can add also?
Azure DevOps is a long story. To make it short, we cannot clone an Azure DevOps repository. We use a library called GoGit, which is the Git implementation in Go. It's widely used, but GoGit implements Git version 1 API, the Git version 1. And seems that Azure DevOps doesn't implement V1 completely. So it's not a full implementation of V1. Azure DevOps has a full implementation of version 2 of Git, but version 2 is not implemented in GoGit. We have to figure out a way to make this work. One option will be to fork GoGit inside Flux Dev organization and implementing version 2 from scratch. I don't know how many months it will take and how much time. But yeah, I don't have a good solution. Maybe Microsoft could implement V1.
Yeah, I could try to reach out to some people at Microsoft maybe and see what they can do about this. I don't think they can implement V1, but I can talk to some people. Yeah, so that's gonna be a problem for me in the future then, I guess, because I have a lot of customers that run Azure DevOps.
Yeah. Maybe there's some creative things you could do with mirroring from like a V2 provider to a V1 as well.
Yeah.
Yeah, or there is the open issue for GoGit. It's 1058 on this problem.
Yeah, we have an issue opened in source controller around. I can give you a link.
While we were talking about Git also, so there is, I don't know, there is the project also, the Git like DSL that you've built, or I don't know who built that. That's also part of the Flux project, right? The source controller uses some sort of abstract, some GoGit library, right? That you've built. Or am I mistaken?
Yeah, the project is called GoGit Providers, and the goal of that project is to help us extend the toolkit bootstrap command. So now the bootstrap command creates a GitHub or a GitLab repository, sets up deployment keys, sets up teams for you, and gives teams access to that repo and so on. And
should we implement the status command there, maybe?
Yeah, it could be an option. The GoGit provider library is all around managing repositories, like creating them and so on. Yeah, we could look at if it makes sense for the status update to be placed in that. The goal will be for the GoGit providers to extend beyond GitHub and GitLab. For example, we want to get Bitbucket support in there. There are two Bitbucket implementations, the Bitbucket server, which you can run on-prem, and the Bitbucket SaaS, or I don't know how they call it. there are two different APIs. So we are looking to implement that as well. So you can do GoTK, Bootstrap, yeah, Bitbucket, and it will create the repo and everything for you.
Okay.
But for the GitLab status update, I would implement it directly in notification controller, then maybe refactor it out at some point in GoGit providers when GoGit providers will get the GitLab implementation. Right now, GoGit providers is in the works.
Yeah.
Doesn't have all the things that we need.
Yeah, that's fine. I'll do that.
Great. Haley, you have an update for us?
Just that I'm working on yeah, I guess this is a fine place to say. So I found a small like privilege escalation thing, and it only occurs when you are running a customized controller with a kube config that has certificates. So if your kube config is only using a service account token, such as like when it's automatically, or rather, there's no kube config when you are running inside of a pod's SA environment, then there's nothing to worry about. But we should likely patch this and release we could use GitHub's CVE thing. If anyone has an opinion, I know some of us are likely running a customized controller in various environments.
So if you run customized controller with the kubeconfig does not provision inside the cluster when you run it locally, you're saying?
Yes. Then basically the service accounts do not. This has to do with a behavior which I think is a little bit dangerous in kubectl, which is that if you use kubectl token and you are on a kube config that already has a selected user, then there's an order of precedence for the fields. So if you need to basically invalidate the user or create a new one inside of the kube config in order for it to function properly. Otherwise, you can pass token and it will silently ignore the fact that you've passed it. You'll still have the full effect of whatever user is authenticated. So this, because we call it service account impersonation, but really what we're doing is fetching service account tokens. I'm just interested in, I think the simplest patch for this is to just use the user impersonation feature. There are some trade-offs here because user impersonation is not enabled in cloud-facing like IAM user accounts by default, but it should be enabled on all cluster admin accounts inside most clusters at least. We could test for that or install our own RBAC. But I was going to open these patches. I definitely just wanted to chat with some people about it first, just to have a human conversation, just closing that there is this detail of privilege escalation. And if we stick with the token implementation for the SA stuff, trade-off here being that you need global access to secrets across the namespaces, then we can figure out a customized controller will need to create a just-in-time kube config, which is not that hard to do, and we'll just modify it with the right things. And Helm controller, the patch is not, it's not susceptible to this because we can control the way that the kube client is generated. So.
Yeah, I've been So the first version of customized controller used kubectl as to impersonate a service account. That didn't work on GKE.
Did it not work on GKE in a pod, or
Yeah.
just okay, cool.
And I had GKE installed with that security feature. I forgot. Yeah. Anyway, on EKS it worked until I used that service account and bind the NIME role to it. Then it stopped working. The token fetching from a service account works across the board. There's no issues there. In terms of customized controller, how I see it, how the impersonation should work, cluster admin should add a service account and a namespace to the Git repo. Customized controller will create that namespace, that service account. Then the cluster admin will say, hey, for that particular team, I want everything that's applied to run on this service account. So it's the customized controller who creates the service account and the namespace. Reading the secret should be no security issue at all because it creates it on its own, right? My concern with the token is that, as you said, tokens can expire, and I'm not convinced if kubelet will replace the token or will add the new token to that array. So this is something we have to test, and if the token is appended, the new token, then we have to figure out which is the latest token for that service account and use that one instead of the first one in the array, what we are doing today.
Yeah, I will. I want to look a little bit into how these failure modes for the IAM stuff regarding impersonation, because I just want to make sure that we're not holding it wrong in the way that, because like this is the feature that supports the use case for something acting as another user. There are some compelling like ways that it simplifies things. For one, like the controller will not have to have access to secrets, like as the actual controller service account itself. The other bit is that when you impersonate a user, the user doesn't have to have a matching object inside of the cluster. So you could impersonate a service account, but you could also impersonate any string, and that string would actually collide with RBAC. So it's maybe one or even two, just one object less to create, because it would just match the string in the RBAC that's bound to your roles. So there's no round trip on getting a secret, no need for access to the secrets, and you wouldn't even need to create a service account necessarily if you decided to impersonate some other namespace string.
Mm-hmm.
Yeah, the IAM thing not working in Kube as a service is certainly, it's interesting if that's bound to service accounts or how it's restricted. That would be good to understand. There's certainly no problem with submitting a patch to Helm controller that does the service account token fetching. I can do that. That is a good approach for the moment. But I do believe that getting service account for Helm controller is a necessary step to support our multi-tenancy needs.
Yes, for sure.
So I can go ahead and finish that up. I did submit a PR to Helm yesterday that adds support for the impersonation flags, just because I was in there looking at stuff. Scott might not be on the call anymore, but maybe I'll contact another Helm maintainer. And then as far as figuring out what to do with the CVE situation, shall we try to use the GitHub disclosure feature on a patch that just creates a new kube config then? We don't have we have unanswered questions right now on using impersonation directly as opposed to fetching the service account tokens. The service account behavior works and we know that people are already using it. And we just need to fix the behavior in the case of kubectl. So how does that sound as far as a patch and dealing with that security situation?
I would do it in the open. I don't think it's an issue. There is no CVs for alpha releases. Like we are on 0.0 something, right? So if you run that, you should be aware that breaking changes are happening and security is in shift.
Okay. So yeah, we don't need to obviously hide anything, but we should do some disclosure. That sounds fine to me as long as we're loud about don't use the previous alpha version of this.
Yeah. Create an issue. Create an issue on customized controller repo explaining the vulnerability, and then a pull request that fixes it. And we'll include it in the release notes. When the release, we have this issue previously. We have to upgrade to 0.0.11 to fix it.
Sounds good.
Great. Thank you, Lee. Any other things? John, you want to say something?
No, nothing in particular. Just coming to see what's happening. We're starting to use the V2, and I just wanted to check in, see if we can contribute some.
Yeah, we have a bunch of issues in the toolkit repository where the CLI is. We are looking at covering more fields from the API with the CLI. So the idea is that maybe you don't want to write YAMLs by hand and deal with typos and all of that. So the CLI with the CLI should be able to generate YAMLs for your Git with -- export. So you can say, for example, go tk create Helm release. You give all the fields as flags in there, then you type -- export, and that creates the YAML for you. Or if you don't do -- export, then it automatically creates it on the cluster. So you can, let's say, if you have a dev cluster, then you can play around with different APIs, and once you settled on something, then you can export what's on your dev cluster, store it on your Git repo, then apply it on a staging cluster, and so on. So we have no support right now in the CLI for all the notification API objects. Like, for example, if you want to create a receiver from GitHub that will trigger synchronization when you say, push something to a repository, don't want to wait 5 minutes, 10 minutes, whatever you've set in the source controller. So you want to use the webhook to trigger it. We don't have that currently in the CLI. It should be something like go tk create receiver -- URL -- authentication, and so on. So those are some things that I think are easy to pick up. I know Scott was looking at the notification part, but we have a different issue for Helm releases. We want to cover all the fields. Are you using Helm, John?
Well, yeah, we're looking to bring in Helm along with the toolkit version 2. The way we're kind of migrating folks over to Kubernetes now, we're going to end up with probably about 100 clusters in prod. So that's kind of the use case. We don't want to have to, manually point Jenkins at each one and run things. So yeah, we're shifting the kind of paradigm too. We're doing a lot of things are moving at the same time. So yeah, it'd likely be Helm, and that's how we're going to manage kind of the stuff that we roll into what we call our platform, and then the app dev, like the rest of the team that creates the business functionality. That's going to be something else possibly, but we might roll it into Helm too.
Mm-hmm. Yeah, we want to make this as smooth as possible to. So the current idea is you have a Git repo that is owned by the platform team, and on that repository in the documentation I called it fleet infrastructure. Let's say you have this Git repository, and there you will declare all your clusters, and you will define the sources that should be reconciled on the clusters. Then your app teams will create pull requests to that fleet repository to add their own customization and probably Helm releases. Say, hey, I have this app. I want to deploy it on these 100 clusters or whatever. I will add it to the base directory, let's say customization that reference my app repo. And then you as a cluster admin, you can include that customization in all your clusters or part of them and so on, because I'm thinking you don't want to copy paste that Helm release or that customization definition 100 times if you have 100 clusters. So the idea is in that fleet repo to have a base directory. That's where you declare, like, let's say, everything that has to be deployed. Then for each cluster, you can change some things. For example, on a Helm release, maybe you want some particular values to run on a cluster group. One thing here, let's say you are deploying an ALB ingress controller or something like that, that needs to know what is the region that I'm running, right? So the region name, maybe you want to configure the region name for each group of clusters, right? So I want for us to write a documentation on on various ways of structuring a fleet repository, because there are many ways you can do it. With customized base is just an example, but you can easily have like a repository for group of clusters and add those repositories into the fleet repo. So maybe the fleet repo will be like have just a bunch of reference to other repositories, and there is where all the things happen. And I think this type of organization depends a lot on how your company, how organization works, how teams are collaborating with each other. For some organization, it's okay to have the dev teams opening pull requests on for the platform team, but for other organization, maybe there are like a different layer. So it's not a single platform team. Maybe there are more than one, and then each platform team should have its own repo and so on.
Mm-hmm.
And because of it's with the toolkit is possible now to add a bunch of repos to define the cluster state. It also opens up to a lot of mistakes. For example, two teams can have the same definition of the same deployment in their repositories, and because they cannot see each other repositories, they'll not know that they have the same thing in there, right? So it will be, they will be overriding that app from multiple repos and so on. And we are trying to solve this with what Leo was talking about with service account impersonation. I imagine that each team should have a service account, and the platform admin provisions that, and the service account has limited access to the cluster. So even if you are doing a mistake and you are adding, let's say, a Helm release that will override something in another team's namespace, if you are using service account that doesn't allow you to actually do that, then you just get an error and say, hey, I cannot apply this object. You're not allowed to modify, I don't know, that particular namespace. So that's one approach. Another approach that I was thinking about is integrating with Gatekeeper from the OPA project. And for a cluster admin, we could say in Gatekeeper, hey, I'm allowing you to add Helm releases in your Git repo, but when that Helm release gets applied on a cluster, it needs to run under that service account. And if it's not there, we should just reject the Helm release, because then it will run as cluster admin and can change whatever, right? So there are different ways of enforcing this type of security. Of course, you can do it at the repo level with pull requests, you review those changes and so on, but you should also be able to do it at apply time and runtime, and that's only possible with something that runs in your cluster and imposes some policies. And I think Gatekeeper could work very, very well with what we are doing here, but I didn't have time to actually start writing Rego rules for the toolkit objects. But that's something that should be doable and should help a lot dealing with hundreds of clusters and many teams in that regard. Are you using Gatekeeper, or have you looked at it?
No, our compliance team so far has been kind of on paper and Excel spreadsheets. So we're getting into the compliance as code area now. For context, I work for a healthcare company that rolls up to United Healthcare eventually, but we're kind of a startup they acquired. So we're a little newer in our thinking, but still we face some of the compliance hurdles that just comes with the industry.
Mm.
So yeah, it's working so far. It's working well. We're kind of, it's a POC right now, and we're kicking the tires. But I think it's going to work out ultimately from what initial kind of experiments have showed.
Cool.
Mm-hmm. One thing I've been looking to understand is just the use case for applying with a service account that's not in the namespace as the Helm release. And just like to know if anyone is using this or wants to advocate for this particular use case. Same thing for the customized controller as well, using a service account that's not in the same namespace as the customization.
Would that make sense?
Right now, the service account reference, I believe, is cross namespace. So it's more, yeah, I'm asking would it make sense? Because currently I believe it's supported.
Yeah, now why I made it cross namespaces is because I don't think we should impose one team equals one namespace. I think a dev team can own more than one namespace. And why I think that is because namespaces shouldn't be tied to a particular team, should be tied to a role. And let's say maybe a team is developing some microservices, and maybe they want to have a database namespace where they put their stateful sets and an apps namespace where they put their applications, right? And you can have a customization object that applies all the stateful sets and also applies the applications. And if you want to use impersonation for that, then you'll be choosing one of those two namespaces to create the service account. Then you'll have a cluster role binding for both namespaces on that service account, right? But that's the reason why it supports cross namespace, because I don't want to enforce this kind of mentality, a team equals a namespace. I want people to be able to choose what they want for their namespaces representation.
Yeah, I believe that role bindings are, the UX is typically within the same namespace for a namespace level role binding. But if I'm not mistaken, the object is also cross namespace. So there are a lot of topologies that you can create with service accounts and role bindings. Like Scott says, it's fairly common for some orgs to have a namespace crack.
Yep. Yeah, so how you can do it today, for example, you can create a cluster role that gives you access to everything. Then you create a service account in a particular namespace, and you do a role binding, not a cluster role binding, for that admin role. What that means is that that particular service account cannot do anything in the cluster, only in that namespace. Then you say, hey, but this team also needs the same kind of access to the database namespace. Then you'll be creating a cluster role binding for a role in that second namespace. And you still get restricted to 2 namespaces without having to create 2 service accounts. Right. Of course, you could create 2 service accounts, create 2 customization objects, and set each service account there. But I don't think we should be enforcing this kind of limitation, especially that Kubernetes allows you to give a service account reach to more than 1 namespace without global reach. So yeah, I don't think we can drop the cross namespace field from the service account. I don't think it's okay to do that. We'll have to keep it. Now, for example, with Gatekeeper, you could say, for this list of namespaces, only these service accounts are available, right? And this is how you can actually enforce the link between them.
Yeah, I think that's the major question, is like, what are reasonable defaults for that kind of behavior, as well as like what are the best ways for people to express what they mean, like beyond the defaults? Because I don't think like it's a reasonable default for somebody who has access to create a Helm release in a cluster without Gatekeeper to, declare that they want to apply the Helm chart with cluster admin. It's just not since the controller will install with, looking at every single namespace and have access to impersonate any service account in the cluster. It seems a little bit overzealous, and we should encourage people to do the right thing, because many people won't understand the security model without being coerced into the proper behaviors that are most likely to make them successful. Yeah, for me, if we are not installing Gatekeeper for the user with the number of components that Toolkit is installing, I think we should support a policy object that the controller considers directly. This also has to do with things like performance. When you add Gatekeeper to a cluster, it needs to be configured properly. And if we do this directly in Helm controller and customized controller, where it considers the policy object before allowing impersonation, then we can avoid that line of issues.
Yeah, good point. So right now it's very different what happens in customized controller and Helm controller. Customized controller will not react to customizations in any namespace, only in the GitOps system namespace where it's being deployed. And the idea is that the platform team is in charge of the GitOps system namespace. No one else can create objects there on the fly. Everybody else has to do it through Git. And if you place something in Git with the GitOps system namespace as the destination, then the cluster admin will have to approve that. So in a way, service accounts in customizations are managed by the platform team. But for Helm releases, that's not the case. Helm controller watches the whole cluster, and when it sees a Helm release, it acts on it and installs it, right? So theoretically, anyone with access to the Git repository, not to the GitOps system namespace, can place there a Helm release that, I don't know, does whatever you want to do on the cluster, right?
Yeah.
So first step is add the impersonation capability to Helm controller. Then I was thinking of two modes when you install the toolkit. By default, Helm controller will only listen to things in its own namespace, but you can also install the toolkit with, let's say, free for all option, where both customized controller and Helm controller just listen to the whole cluster, and then you assume that everybody that has access to the Git repo is the cluster admin, and that's it. That's one approach.
Yeah, Scott, what were you gonna ask? Mention?
While Scott is figuring out his audio settings, I have a small note though, because while you can create a Helm release in any namespace, it will only use charts from authorized artifacts, because it only uses or it creates the Helm chart in the GitOps namespace. And the source controller by default only creates artifacts from the GitOps namespace. But to be able to create a Helm chart, either a Git repository, which has been authorized by a cluster admin, or a Helm repository, which has been authorized by a cluster admin, must exist in the GitOps namespace. So you can only create Helm releases that refer to something that has been authorized by some cluster admin. So it's not a wild or blind install.
It is with the Git repository, right?
No, because the Git repository has to exist in the GitOps system namespace.
Yeah. So let's say if I want to take over a cluster, I'll create a Git repository with just a deployment. I submit that as a pull request. The cluster platform admin, whatever, approves it. Then I'm committing to that repository a service account with a cluster role binding in that Helm chart, and Helm controller will apply it. Because the cluster admin cannot verify every single commit in thousands of repositories.
Yes. In general, I don't think that relying on the administrator to gate all objects to the cluster will be a solution that works for people with many teams and clusters. And we need to, but what I see is we are missing this case of handling multi-tenancy where there is an element of self-service that can still be constrained by administrative policies. So with the way that like I see Helm controller and customized controller being installed by the toolkit as a singleton in the cluster, this is fundamentally different from what we were doing with Flux Dev, where people had the freedom as long as they had the ability to deploy into a namespace to apply whatever Helm releases and Git repositories they had, and that was bound effectively by their RBAC. So now that we have the singleton in the cluster, if we want to support this kind of self-service freedom, but still bound it by whatever service accounts or RBAC those users have available to them, then we need to allow the cluster administrator to express, that, across the cluster, Helm releases are allowed to use, service accounts in the same namespace, right? And like that seems like a pretty it's a very easy to express, easy to implement, and it seems like a sane default. right? And if you actually did that same tenancy model with customized controller, you would not necessarily have to have a central repository where the administrator approves Git sources. And you would not, you could have that central repo, but then have more expressive topologies where a team has their own control repo that is synced from the admin namespace, right? And then the team's control repo is bound by whatever RBAC they are allowed to use. Right? So they could still create Git sources, but theirs are only allowed to be using service accounts in the same namespace.
To sort this out, we cannot just rely on referencing a service account in the object itself. We need a separate object, like a policy, that no one can apply on the cluster, except the cluster.
Except for the administrator.
Yeah.
Yep. And that would likely be in the GitHub system namespace.
Yeah, of course.
Adjacent to the controller. And if you had multiple controllers in the cluster, then they would each be able to read their own configuration in separate namespaces. So
Yeah, but we definitely need something else than the Helm release or the Git repository or the customization custom resource to enforce. We either define our own policy and we have our own policy agent, let's say, or we use something like Gatekeeper. But yeah, I'm guessing what you are proposing is to come up with a simple to understand multi-tenancy model and enforce that through our own policy object. And for advanced use cases, only then you have to install Gatekeeper and write Rego and all.
Yes.
All that.
Yeah, I think that's reasonable. If somebody wants to, start using team names and organization count rules and all that, they can write their own Gatekeeper functions. But I think that there's probably a very effective pattern that relies on namespaces or something. Mm-hmm. It's one of the reasons why I just was thinking about it before this call, and that's why I was asking if we really need people normally to be applying things from service accounts that are not in the same namespace as the resource, because it's a very effective way to implement a policy, but that's defaulted. You could opt in beyond it, right? But even if a team, say, has a management namespace for their apps, right, they could still just rely on like having an applier essay inside of the source namespace that has role bindings in all of the target namespaces.
Yep. Could work.
So, cool.
For Helm release, it's trickier because a Helm release can have a target namespace. So you create the Helm release in a namespace, then you say target namespace, this other namespace, right? So the service account, if we impose the service account, has to be where the Helm release is, but the Helm release acts on a different namespace, then you see it's an issue. It's an issue in terms of it will confuse the users, right? Because if we say service account has to be in the same namespace as your object, it is in a way, but that object changes a Helm release, installs the actual Helm in a different namespace and so on, right?
But it's the same as referring to config maps and secrets, right? They also have to live in the same namespace as the Helm release.
Yep.
So I don't think it would confuse users that much, and I think the amount of users using a target namespace is only a small fraction and probably are more aware of what they're doing.
Yeah. Okay, we are way over time. Thank you everyone for joining. Any last words from anyone? If not, have a nice end of week and a nice weekend. I'll see you all next time. Bye.
Thanks everyone.
See you guys. Bye.
Bye.
Bye.